Alright, so today we're going to talk about one of the first sort of more complicated statistical analyses that you will need to do. So this is the extremely helpful measure of variability called standard deviation, and this is a measure of variability. In particular, standard deviations are a measure of how much, on average, how much do the scores vary from the mean. Okay. It's a very, very, very useful measurement of variability. It's one of the most common ones in all of psychology. The critical things to understand is that it's about varying from the mean, and it's an average. If you can remember those things, that it's an average, and it's an average measure of variability from the mean, then you will understand what it is in a much better way than people that just sort of see it as a number. Most of the time you see a standard deviation, it will be linked to a mean, right? Mean. Most of the time you'll see it this way in a journal article. The mean equals some number here, comma, standard deviation equals some number here. And that's the way you'll normally see it written. So we're going to talk about how exactly we calculate this standard deviation. All right, so let's talk for a minute about the actual formula. The formula, statistically, they abbreviate it as S. So I know that we've now given you multiple variations, but S is just equal to standard deviation. Okay? So S is equal to, now don't panic, there are going to be some numbers here, or not numbers, but there's going to be some arithmetic signs and things like that. Don't panic. The square root of a quantity, right? And that quantity is equal to the sum of the deviation scores, where every deviation score is the score, distance from the mean, squared, I know some of you are panicking now, divided by the number of cases. Okay, so let's go over this. Let's break it down one more time. Standard deviation is equal to the sum, which means to add up what comes behind it, every score minus the mean squared, right, divided by the number of cases. Okay? It looks intimidating. It's not. I'm going to give you a really easy example to get us started with. All right? So let's get to the example. Don't panic until we do the example. All right, let's clear this off. Okay. So let's say that we have a set of scores. Okay? And the scores are 1, 2, and 3. So 1 is Joe, 2 is Sarah, and 3 is Mike. Okay? We need to, once we have the scores, we should recopy down the formula. Okay? Standard deviation is equal to the square root of, I'm going to use a couple of different colors, the sum of the quantity of every score minus the mean, okay, divided by n. Okay? So let's do the easy part first, which is n. How many cases are there? N equals equals the number of cases. Joe plus Sarah plus, is that Mike or Milk? It should say Mike. Mike. Okay, so n is equal to 3. So we now know this. Now, let's go on to calculating the mean. The mean is equal to the sum of the scores divided by the number of cases. We know the number of cases already. 3. The sum of the scores, 1 plus 2 is 3 plus 3 is 6. 6 divided by 2 is 2. So now we have the mean. Now the next bit gets a little bit more complicated. We have to calculate the deviation scores and then square them. This is, let's see, this is this part here, the deviation scores, and then you need to square them. Okay? So, you need to lay out the scores one more time. 1, 2, 3. And then we need to subtract the mean from them. X minus the mean. Okay? So the mean is 2. Minus 2. Minus 2. Minus 2. Okay? So I'm going to put this in parentheses just to keep us sort of consistent. Negative 1. 0, 1. Signs matter. Don't forget the sign. Okay? If you sum up this column of numbers, the answer that you should always get is 0. Okay? I know you're thinking, well, if you put a 0 in there and then square it, but we're not going to do that. Okay? What we do first is we square the deviation scores. So we take each of the scores and square them. So 1 squared is 1. 0 squared is 0. 1 squared is 1. And then we sum them up. Okay? So remember, parentheses exponent, right? Please excuse my dear Aunt Sally. You have to do this in the right order. Otherwise, you will always get a standard deviation of 0. Okay? And I'll talk about why that doesn't make any sense in a minute. So this is x minus mean squared. Okay? So you sum this up, 2. And then from here, we just plug it in. Wait a minute. Okay. So we just plug it in to here, and then we do the calculations. So let's try to fit that in. Let's try to. Oh, look at that. Okay. I didn't know it did that. Okay, so standard deviation is equal to the square root of the sum of, so it's equal to this number here, right? This is equal to the sum of those numbers, 2 divided by n, which is 3, and then you take the square root. Standard deviation is equal to 0.66 repeating divided by the square root of that value, which is, to use a calculator quickly, standard deviation is equal to 0.82. Okay? Let's talk for a minute about why the standard deviation of this set of numbers isn't 0 and can't be 0. So let's go ahead and just clear all of this off. Alright, so we had a set of numbers, right? 1, 2, 3. And this set of numbers was, what was it? It was Joe, Sarah, and Mike, right? Not Milk, Mike. The standard deviation is an average amount of variability, right? Excuse me, my spelling is horrible today. It's an average amount of variability, okay? Wow, my spelling is extra bad today. Let's try that one more time. Average variability. Okay, it's an average measure of variability. If the standard deviation is 0, which can happen, this means that the average variability is nothing. In other words, there is no variability. So a standard deviation equals 0 means no variability. Okay? So is there variability amongst these scores? Well, one person got a 1, one person got a 2, and one person got a 3. Are they all the same? No. Henceforth, there's variability. So the number can't be 0. Standard deviation in this case cannot be 0 given this set of numbers. Right? It just wouldn't make any sense. Alright. Let's talk about a time when standard deviation can be 0. When standard deviation is 0, it means that all the scores are the same. So standard deviation of 0 just means that all of the scores are exactly alike. So an example of that would be if Mike got a 3 and Sarah got a 3 and Tony got a 3. Everybody has to get the exact same score for there to be a 0. Standard deviation. And you don't even need to calculate this. You can look at it and go, they all got the same score. The standard deviation has to be 0. Alright, let's do one more example real quick. So the first thing we need to do is to get our scores. Let's do a slightly bigger data set. Let's not freak out though. So let's say it's 1, 2, 2, 3, 4, 4, and 5. Okay? The next thing we need to do is we need to copy down our formula. Let's put the formula over here. Standard deviation is equal to the square root of the sum of the deviation scores squared. And then down here we have n. Okay? Let's calculate n first. N is equal to 1, 2, 3, 4, 5, 6, 7. N is equal to 7. So we have this one done. Let's just put a little check mark next to it. Check. Good. Alright, the next thing we need to do is to calculate the mean. The mean is equal to the sum of the scores divided by n. We know n is 7. 7. So we need to add up these scores. So 1 plus 2 is 3, plus 3, 1 plus 2 is 3, plus 2 is 5. You know what? Let's cheat and grab a calculator real quick. So 1 plus 2 plus 2 plus 3 plus 4 plus 4 plus 5 is equal to 21. So the sum of x, right, is 21. 21 divided by 7. 21 divided by 7 is equal to 21 divided by 7 is equal to 3. Okay, so now we have the mean. So let's put a little check next to that. Okay, now we need the deviation scores, right? That's this part here. Okay, so we need x minus the mean. X minus the mean. So we need to take each of these scores and subtract out 3, right? Minus 3, minus 3, minus 3, minus 3, minus 3, minus 3, minus 3. Do it for each one. gives us -2, -1, -1, 0, 1, 1, 2. Now if we sum up this set of numbers, we should get 0, which we will. You can see that they pretty much cancel each other out. It's one of the reasons why I like this set of numbers. Okay, so you add that up, you get 0. That's not going to work, though. You have to square each one. So we calculated this bit. Right? We need to square them next. So you take each one and square it. You get 4, 1, 1, 0, 1, 1, and 4. And then you add them up. So this is the sum of x minus the mean squared, which we did. So we just add up this column of numbers here to get this value. 4 plus 2 is 10, plus 2, sorry, 4 plus 2 is not 10. 4 plus 2 is 6, plus 4 is 10, plus 2 is 12. Let's check again. 4 plus 4 plus 4, yeah, 12. Okay, so now we have that, and then we just plug it in. Okay, so I will highlight this as we go along. Let's start with n, right? So standard deviation equals the square root of n, 7. Okay. Next, the deviation scores, which is 12. 12. Okay. And we don't even need the mean. We just needed that as a step to calculate the deviation scores. Alright, so let's keep going. Standard deviation is equal to the square root of this value, 12 divided by 7. 1, 2, 3, 4, 5, 6. Okay, so 12 divided by 7. So 12 divided by 7 gives us something like 1.7. 12 divided by 7 is equal to, yeah, 1.71. 1. We need to take the square root of that. Square root. So standard deviation is equal to 1.31 approximately. Alright, so you can see that this is pretty simple. One of the things that people tend not to understand, right, is that standard deviations are in the unit of measurement. Okay, so let's say that we have, we're looking at average income. So an average income, we would be using, the unit would be something like dollars or dollars salary, something like that. And let's say that the standard deviation is equal to, let's say it's something bizarre like 100,000. That means that the standard deviation is actually $100,000, right? That's large and meaningful, right? Let's say that you're doing this with IQ scores. The standard deviation for IQ scores is actually about 10, I think, the last time I checked on IQ scores. I'm not that kind of psychologist. The standard deviation was 10, okay? So that means it's 10 IQ points. So sometimes students will calculate the standard deviation for something, and so they'll calculate the standard deviation for something, and they'll get a number like 52. Well, that's fine, and they'll think, oh, that's a huge standard deviation. But if we're talking about a company of, let's say, 1 million employees, and the standard deviation is $52, That's not large at all. That's actually really, really, really small, right? That means that they're almost all making the same amount of money. Or that's what it would indicate if you didn't have skew and so on and so forth, okay? So this is actually a pretty good, an interesting thing to find, and it would actually lead me to question whether or not this was correct. It's almost too small, okay? Now let's say that you did, you gave a test to people, and the standard deviation for the test was 20, and this is out of a 100-point test, right? This standard deviation is 20 percentage points, right? So standard deviation on a test, that's huge, right? So this number matters depending upon what it is in, what units it's in. So on a test, this would be really, really noteworthy. If we're talking about average income and the standard deviation was $20, then that would be really, really meaningless. Okay? All right. So thank you for hanging out with me and learning about standard deviation. As a reminder, standard deviation is an average measure of variability from the mean. All right. Thanks a lot, and I will see you in the next video.